Picture this, a sealed glass jar, a screw-on lid, and a treat locked inside. Now put a 2-year-old human toddler in front of it. Chances are they'll cry, bang it on the table, maybe hand it to an adult. Now put an octopus in front of that same jar. Give it less than a minute. Watch it unscrew the lid from the inside out, using arms it's never used for this exact task before, and calmly walk away with the prize. This isn't a trick. It's not trained. It's a documented behavior, and it raises a question that should genuinely unsettle you. How does an animal with no bones, no shell, and a brain the size of a walnut outsmart a human toddler at problem solving? Let's get one thing straight before we go further. The octopus is not smarter than a human. That's not what the science says, and we're not here to exaggerate. But in specific tests involving spatial problem solving, tool use, and novel object manipulation, octopuses consistently perform at a level that rivals and sometimes beats very young children. And the reason why is stranger than you'd expect. Here's the first curiosity gap. An octopus has roughly 500 million neurons. That's more than a mouse, more than a rat, and comparable to some small mammals. But here's the twist. Only about a third of those neurons live in its central brain. So where's the rest? In its arms. Literally, in its arms. Each of the octopus's 8 arms contains its own cluster of neurons, essentially a mini-brain, capable of processing sensory information and initiating movement independently of the central brain. Scientists call this a distributed nervous system. In practical terms, it means an octopus's arm can react, explore, and even make micro-decisions without waiting for permission from headquarters. Try to imagine that in human terms. Imagine your hand could taste what it touches, feel the shape of an object without your eyes, and decide how to grip it, all without sending that information to your brain first. That's not metaphor. Octopus arms are covered in chemoreceptors, meaning they can taste through touch. Every sucker along the arm can sense chemical signals in the water, effectively letting the octopus taste and feel a hidden object at the same time. Now here's where the toddler comparison actually earns its place. Developmental psychologists have long used specific benchmark tests to measure problem solving in human children. Things like the detour task, where a treat is placed behind a clear barrier and the subject must figure out an indirect path to reach it. Toddlers around 18 to 24 months typically need multiple attempts before understanding the barrier requires a workaround rather than a direct push. Multiple published studies on octopus cognition, from institutions studying cephalopod behavior, have shown that several octopus species can solve version of these tasks in a single attempt, correctly identifying that a direct route is blocked and that an alternate path exists. Why would evolution build a brain like this in an animal that lives on average only 1 to 2 years? This is where the story gets emotional, not just scientific. Octopuses evolved this way largely because they have no external shell, unlike many of their mollusk relatives. That soft, vulnerable body forced evolution's hand. Without armor, survival meant outsmarting predators rather than outlasting them physically. Every arm needed the ability to react instantly to a threat. A bite, a grab, a change in current without a split-second delay waiting for a central decision. In other words, the octopus's genius isn't an accident. It's the direct evolutionary trade-off for giving up a shell. Now let's talk about tool use, because this is where skeptics used to draw the line. For decades, tool use was considered one of the clearest markers separating intelligent animals from simple reflexive ones. In 2009, researchers documented veined octopuses in the wild collecting discarded coconut shell halves, carrying them across the sea floor. An oddly clumsy, stilted walk on 2 arms while holding the shells with the other 6, and later assembling them together to form a portable shelter. This wasn't a one-time fluke. It was observed repeatedly, in multiple individuals, suggesting the behavior wasn't accidental but intentional forward planning. Carrying an object now for a benefit later is a form of planning that scientists take very seriously when studying animal cognition, because it requires the animal to hold a future goal in mind while performing an unrelated present action. So here's curiosity gap number 3. If octopuses are this capable, why don't we consider them broadly more intelligent than humans? Because intelligence isn't one thing. It's not a single scoreboard. Human intelligence is built around long-term social learning, language, and multi-generational knowledge transfer, none of which apply to octopuses, since most species are solitary and rarely live long enough to teach offspring anything at all. Octopus intelligence, by contrast, appears almost entirely self-taught within a single, short lifetime. Every clever escape, every unscrewed jar, every clever shelter, the individual octopus is figuring it out fresh with no mentor, no manual, and often no second chance to learn from failure before its short life ends. That fact alone reframes everything. This isn't inherited wisdom. It's real-time genius, discovered alone, every single time. Scientists still debate exactly how self-aware octopuses are, and whether their arm-based decision-making constitutes a form of consciousness distributed across the body rather than centralized in one place. This remains an open, actively studied question, not a settled one, and researchers are cautious about overstating claims of animal consciousness without stronger evidence. But here's what is settled. The octopus's ability to solve novel physical puzzles, manipulate objects with intention, and adapt in real time puts it in a category most people never expected from something that looks like a squishy alien. So the next time someone hands a toddler a jar with a locked lid, and hands an octopus the exact same jar, you already know who's finishing first. The real mystery isn't why the octopus is so clever. It's what else is quietly thinking, tasting, and problem-solving in the ocean that we've barely begun to understand.